awesome day today. I know I am. It's the butt crack of dawn out here in Chicago, and I'm going to be working with a concrete precaster to bring new and emerging technologies to the forefront of the Chicago precast market. So before I head out of here and get to work, actually we're going to be doing a nice breakfast, talking about the mixes that we're going to be kicking the tires and lighting the fires on today. I wanted to go over Q&A. Got a bunch of them. I think I got about, holy moly, guacamole. I've got a lot of questions to go through, and I want to apologize if we haven't gotten to these YouTube questions that y'all have been putting out there. We're doing our best to get on top of these questions as quickly as possible, but there are a lot of questions, as you can see, and a lot of these questions not only come from YouTube, but they also come from these presentations that we give throughout the world. And the unfortunate reality is sometimes we're only given 10 to 15 minutes to give a presentation, or even 30 minutes to give a presentation, but there's only like 5 to 10 minutes for Q&A. So the questions that I don't have time to answer, either I answer them at the end, or I have one of our colleagues going out to the audience and having the folks in the audience writing the questions down so we can get to them. So it's another Q&A day. All right, so this is one of my favorite questions, and we're actually going to be doing a webinar on this, which is how does cement chemistry impact the efficiency of polycarboxylate style high range water reducers? Love this question. So just to give you a little bit of background, growing up in the concrete industry, I was really put into the practical side of it first, starting at a very young age. When I finally got into the research component, the first thing that I started working on were these polycarboxylate style high range water reducers. And this was a really big time in the concrete industry. This was a brand new technology that was really breaking the surly bonds of what we understood we could do with water reduction, and then also creating self-consolidating concretes that consolidate under their own weight due to the force of gravity. They kind of fit together like puzzle pieces, which is not totally because of high-range water reducers, but a large component of that concrete type was the use of polycarboxylate style high-range water reducers. So this is early 2000s, still had a full head of majestic hair, and I was working for a company called Lafarge North America, they divested all their assets back in 2008, 2009 during the recession, and now they're only getting back into the United States here in the last year or so. But I was working with them on polycarboxylates. We were working with a company called WR Grace. We were using a product called Adva 100, which I don't know if it's still available here in the US, but it was one of the first high-range water reducers that we really had. And we were working with a very matured concrete management staff, folks that had been in the industry for 20 or 30 years and were very used to working with the product. And oh gosh, there was so much resistance to using the high-range water reducer. I actually had quality control managers literally close their eyes and throw the high-range water reducer in the back of the truck. And when things went wrong, they look at me and say, well, what the hell's wrong with your admixture? Or there's something wrong. Back to the drawing board, Belkowitz. And more often than not, it was the quality control manager's negligence of learning how to use, or ignorance in using a new material, or disdain, or they just wanted to resist using it. But when we started using polycarboxylate style high range water reducers over an extended period of time, we noticed a phenomena. And what I mean by that is we noticed that there was a reduction in the high-range water reducer, or I should say a change in the high-range water reducer efficiency based on the change in the cement that we used throughout the world. So for that Adva 100, if we used a very high alkali cement, the high-range water reducer operated beautifully, 5 to 6 ounces per hundredweight, creamy and dreamy, 28-inch spread, 28-inch spread, 60 minutes, 90 minutes, maybe we're losing an inch, maybe an inch and a half of spread, but still creamy and dreamy and nice and fluid like we want from an SCC mix. Now we went to a much lower alkali cement, or if we put some, what's the phrase I'm looking for, supplementary cementitious materials into the concrete, we took our 5 to 6 ounces per hundredweight, and we had to sometimes double it, maybe 2.5 times. And we weren't getting the same effects. We weren't getting that slump retention. We weren't even getting the initial slump unless we went up to these mega high dosages. And in doing so, we ultimately caused a lot of retardation because of the other secondary or non-active materials in this high-range water reducer blend. And we ended up finding out, and we're going to be hosting a long webinar on this with PDHs and CEUs and all that jazz. But what we found is that the change in cement chemistry, sulfates, soluble alkalis, caused an issue with the adsorption of the back of the polycarboxylate chain to the surface of the cement particle. And ultimately what the idea is with polycarboxylate style high range water reducers, you get something called steric repulsion. And what you see is this polycarboxylate chain, this PCP chain, adsorbs to the cement particle surface and so on the other part of that surface, or on the other side of that chain, you have all the teeth from the polycarboxylate chain, and those teeth are going to repel other adjacent teeth that are attached to other adjacent cement particles. And in that we have that pushing effect, or that deflocculation for that hydrated cement matrix, for that cement paste, to give us that, not only that water reduction, but that fluidity. So again, it has to be a mechanical adsorption to that cement particle surface so it can push that cement particle away from adjacent cement particles. The problem lies, if you don't have the right cement chemistry, instead of getting that mechanical absorption, we almost get like a lever effect, where you still have the polycarboxylate on the surface, but it's not as efficient. Those forces, instead of radiating down to, or not radiating, but transferring down to the cement particle through the teeth, it kind of just moves it back and forth. So you're seeing this inefficiency from the lack of mechanical action from that steric repulsion. And ultimately, that what we found, it was caused by the change in chemistry. So ultimately what we had to do is create new polycarboxylate chains so that they could really adsorb onto the surface and get that steric repulsion, that mechanical advantage, and causing that deflocculation to create that self-consolidating concrete. So like I said, we're going to be offering a larger presentation on this webinar, if you will, later on during the year. Please let me know if you have any other concrete questions, concrete concerns. We've done a bunch of videos on high-range water reducers, and I'll have Haley throw one of those links down below in the description. Don't forget to like and subscribe. Ding that bell for notifications. Go concrete! It is hot!